Okay, hello everyone. Let's go ahead and get started, please. Hello and welcome everyone. Just wanted to start off today with a few announcements. Oops. Hello, there we go. Hey, yeah, I don't think this microphone is working, so let me use this one for now. Hello everyone, welcome. Let's go ahead and get class started. Just wanted to start today with a few announcements of stuff that's coming up. In fact, we're getting close to something very, very important. Just next week, we're gonna have, can I have your attention please? I'll start when everyone's ready. If you want to hear about the exam. All right, thank you. Very important day coming up next week. We have our first exam on Thursday. So I want to make sure everybody is aware that 1 week from today on Thursday, we're going to have our first exam. It's going to cover everything that we've covered up until and including today. So the stuff that I'm going to be talking about today is going to be on the exam next week. 1 week from today, Professor Nuri is going to be leading an exam review session. So when you come to class on Monday of next week, Professor Nuri is going to go over expectations for the exam and things like that. So I'm not going to spend a whole lot of time talking about exam details now, but I do want to make sure that everybody is aware that the exam is coming up in the very near future, just so that you have that on your radar. I also wanted to make sure to point out that I've also already posted study materials for you to start working on the exam if you want to start practicing. So on Canvas down here you can see there's a big old practice quiz and an exam 1 coding prep repository. I've been posting those for every week actually. I've been posting a practice quiz and a coding repository for the last couple of weeks. There wasn't a coding repo for the first week because it didn't really lend itself so well to those kinds of problems. But as you've probably seen, especially starting with the material that we did last week, a lot less multiple choice, fill in the blank kind of stuff, and a lot more read this code and tell me what it does, or here's a small little code writing problem, do it kind of thing. And those are the kinds of problems that we're gearing you up to get ready for on the exam. So, please, please, please take a look at these coding problems and bring questions next Monday for Professor Nuri. She'll be, here to walk through and get you prepped for the exam in whatever way she can. Trying to think if there's any other announcements I need to make sure you're aware of before I begin. I think that's the main announcement for now. Does anybody have any questions about the schedule or logistics or things like that before I hop into today's topic? Any questions about what's coming up in the next week or two? Okay, fantastic. So today we're gonna go through the material from Module 3, but before I do that, I actually kind of want to take a moment to appreciate how far we've already come. I know it's actually only been a couple of weeks into the semester, and it may feel like we're just getting started, which is true, we are just getting started. There's still a lot more left to come in this class, but we've already covered a significant amount of ground. In fact, I'm going to tell you something that may or may not surprise you. Based on what you already have learned in this class, variables and if statements in particular, but also loops to some degree, you already have the skills to write any computer program that could possibly be written. Which may sound a bit hard to believe, hard to swallow, but it's absolutely 100% true. However, there is sort of a caveat to that, right? There's a big difference between the programs that we're writing and a phone app or a website like a Facebook or something like that, right? And the big difference between the code that we're writing and the programs that you use on a regular basis has to do with higher level techniques, higher level coding techniques to make it so that coding is easier to understand, easier to write, easier to use. So a lot of what we're talking about in the next, for the rest of the semester has to do with coding concepts to not necessarily provide new functionality, but to just make it easier to understand the code, easier to reuse code over and over and over again so that we don't have to rewrite the same thing over and over and over again. And easier to store data and concentrate our data, which is what today's topic is about. Today, Module 3 the topic was arrays. And arrays are the first example of what we like to call data structures as computer scientists. And what I mean by a data structure is that I'm not representing just one single unit, one piece of data, but I'm representing an entire collection of data. But the way that that data is stored turns out to make a big difference. Turns out to have a huge effect on how we write our programs, how we approach our programs. As you'll find out if you take the course after this one, called Data Structures and Algorithms, appropriately enough. But the one I'm going to introduce you to today is called an array, and to kind of justify why this is important, think for a second. If we wanted to, we can make a simple program where we track high temperatures over the course of, let's say, a week. You could consider maybe we would make a variable for the high temperature for each of those 7 days, and that wouldn't be a too terribly unrealistic thing to do. But then consider, what if I wanted to take that program and extend it out over the course of a month, or a year, or a decade? Do I want to create that many variables? The answer is no, probably not. That would be, even looking at a month, that is 30 variables that I would have to create to represent each day of that month, and that already gets to be kind of unwieldy, kind of a lot of variables to have to manage, both mentally in my head and also in the code itself. So as computer scientists, we like to think about data structures and ways to organize our data into collections so that I can have not just one piece of data associated with a name, but a whole collection of data associated with a name. So arrays are our first example that's going to do that. I can store not just one piece of data in an array, but many pieces of data in an array. So I can make, for example, an array with 30 spots in it, one for each day of the month, and then I would have one collection of data. Yes, it has 30 buckets, and we'll talk about how to use those buckets a little bit later on. But now, instead of having one variable for each piece of data, I can have one name refer to a whole collection of data. Instead, it has some very useful things, very useful properties, very useful coding applications. So what I'd like to do is go ahead and dive in. I fully admit that my teaching style is a little bit different than Professor Nuri's. I tend to focus more on actual code examples, writing lots of code examples, working through code examples. I am also going to do some diagrams today as well to show you what's going on with these arrays. But I would encourage you to follow along with me as much as you can, and if you start falling behind, that's totally okay. Raise up that hand. Let me know if you have any questions. I'd be happy to go back and explain anything as I go. But first, let's take a look at the very first example in Module 3. It's called Empty Array Declaration. And if we take a look, this is the first line of code that we see, and we start to see some new little pieces in here, specifically these, we call these square brackets. That's the official term for those characters, are the square brackets. And one of the things that we're trying to train you to do is think, anytime you see these square brackets, your brain should think array. There's some kind of an array work going on here, right? But notice that it's not just the square brackets by themselves, it's the square brackets associated with, what is int an example of? Starts with T? Type, yes. So I can't just use the square brackets by themselves, I have to use the square brackets in association with one of the types that we've already been introduced to. So I'm making, in this case, I would interpret this as I am making an array of integers. I could also make an array of doubles. I could also make an array of strings, right? Any of the data types that we've seen before, if we tack these square brackets on the end, it now becomes not just one integer, but a collection, an array of integers, okay? And so this is our variable name. And then on the right-hand side of the equal sign, we see some other new stuff. I see this new keyword, which is a very important keyword for us, but one that we're not going to talk about a whole lot today, until a little bit today, but we're going to talk about it a whole lot more later on this semester. And then over here, we see that I am creating a new array of integers, but this time in the square brackets, I have a number, with that number representing how many spots I want to have in this array. So these are buckets, and I like to kind of illustrate by coming over here. If I'm making an array called high scores, I like to use Excel or a spreadsheet to help me illustrate my arrays, because the grid structure is a really nice way to think about it. So if I'm making an array of size 10, That's what this is telling me to do. That means that I have 10 buckets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll make it a different color just so we can see. Here's my array. This is my collection of things called high scores. Okay? Right now it is empty, although this is a little bit misleading. It is empty, but it's not like empty. There actually is a value here. There actually is a number in here. Remember, it's an integer array, so I'm not going to find the word high in here, right? That's a string. That doesn't match. That's not an int. But one thing that I think is important for you to be aware of is that when I create a brand new array for the first time, the whole thing is actually going to be filled with, if it's an integer array, it's going to be filled with zeros. And actually, if it's a double array, it's also going to be filled with zeros. What about if it's a string? That's a tricky one. Anybody have an idea of what I would expect to find in a string array? Is it going to be 0? No? Yeah. It's not null. That's a good guess. Yeah. It's going to be empty. Yeah, so it'll look like this. Empty quotes. Quotes with nothing in the middle. We call that the empty string. So when I create a brand new string array for the first time, these would all be filled with quote, quote. But that's not what we're dealing with here. We might deal with that a little bit later on. But for right now, this is what our array looks like after we create it for the very first time. And this is the line of code that creates that array. Everybody with me so far? So if I wanted to do this next one, right, I would say I want to create an array of 5 doubles called prices. All right. I'm creating a double array. So double followed by the square brackets. My brain has been trained to see that and literally say double array or an array of doubles, right? It's not just a double. It's not just an array. It's both. It's an array of doubles, a collection of doubles called prices. And we're going to make that equal to a new array of doubles with, it wants 5 things in it. Okay. And so if we're referring to our diagram, our mental model, what does that look like? I've got now this array called prices, and over here I've got 1, 2, 3, 4, 5 things in this one. But since it's a double, it's also going to be filled with all 0, or 0.0 if that makes you feel better, since it's a double, 0.0. Question? Is it possible to create an array that contains multiple types is the question. No. Unfortunately, not a thing that's possible. If I create an array of doubles, it can only have doubles. It can't have ints, can't have strings, can't have anything else in it. Now, as we move to some of the more advanced coding concepts, we'll see that if I really want an array with multiple things in it, we do have a technique to do that. But it's not really appropriate one for us to talk about for today. So for right now, the answer is no, absolutely not. One type of thing in our array, and only one. Good question, though. I like that you're thinking about it. All right. And so the other thing I want to point out before we move on to our next example is that, while yes, I did say how big these arrays are, if I forget or if I don't know how big an array is, I can always ask. I can ask the question, how big are you? And this is one of our first introductions, although we have seen this a little bit before, to using this dot, right, to connect things together in our code. So I'm saying, what is the length of this high scores array? And that's actually the only thing getting printed. So I would hope, very much hope, that when I print this out, I get an answer of 10. Array high score is declared with size 10. And then just to verify, that this makes sense, if I come up here and I change this number to say 6, for example, and I run this code again, we should hopefully see that, okay, now it's telling me that high scores was declared with the size of 6. So this is always going to tell me what the size of the array is. And one other thing that I think is very important to point out before we move on, once I do this, right, once I create this array, and say that it's got 6 things in it, it forever has that many things in it. I cannot come back later and change the size of that array without stopping the program, changing the code, and restarting the whole program over again from the very beginning. I can't change the size of the array mid-program. That's not a thing that I'm allowed to do. So if you create it with the size 6 at the beginning, that's what you're working with until the program's over. You can't switch it. All right. This is actually just one way to create an array. Let's take a look at another way to create an array, because it's a little bit inconvenient to create arrays that way. If I already have data and I want that data to be in an array, it kind of involves an extra step to create an empty array and then have to fill it. So there's a shortcut that I want to make sure you're aware of, where if we use this syntax, so these are called curly braces, that's the technical term for those guys, it's going to create an array, and these are going to become the values that are within that array as well. So I'm not just creating an array, but I'm also filling it all in one step. The size of the array is based on however many values I put inside of these curly braces. So in this particular example, I'm creating an integer array of size 5. If I come back here and, update my diagram, this time I only have 5 value, 1, 2, 3, 4, 5. And the values that are going to be in that array are very clearly shown here as 99, 98, 98, 88, and 68. So it's going to look something like this, as opposed to being filled with all zeros, which is what we get when we create an empty array. Now, which one you choose, again, is up to you. Do I need an empty array that I'm going to fill up with data later? When might you want to do that? Anybody have an idea of when that might be an acceptable thing to do? Think about what we've been doing in past studios and labs and stuff. Yeah. Go. Hmm? Exactly. Yeah, that's exactly what I was thinking of. If I'm asking a user, a person, to type in some numbers, I don't know what they're going to type in. I have no idea. I can't read their mind. So I'm just going to create an empty array, ask them to type in the values, and then put those values in the array as they go. And I'll show you how to do that in a little bit. If I already know what values I want to use, well, then I can, use the second way of creating an array and make an array with all the stuff in it ready to go right out of the gate. It's up to us as programmers to make the appropriate choice for whatever problem it is that we're trying to solve. Okay? Let's talk about array access. So let's return to that example of, well, I'm going to make an empty array, and then I want to fill it with values. How do we do that? How do we actually get stuff out of an array or put stuff into an array? This is called an array access, hence the name of this exercise. So I want to walk through this step by step using my Excel spreadsheet as kind of an example here as we go through. We create the array, but this time you can see I'm just making it as an empty array. 5 things in it. But all of those things are going to be 0. So for the purposes of this example, this is our starting point, right? The next line of code right here says, go to the array called high scores and look at, whoops, didn't mean to do that, and look at bucket number 0. Now wait a second, bucket number 0 might sound a little bit strange. As human beings, we have been trained since basically, preschool, kindergarten, to start counting from 1. But as computer scientists, we actually generally prefer to start counting from 0. And that is the case here. You're going to see this happen over and over and over again. In fact, let's update our diagram a little bit. This value inside of the brackets has a name. This is called an index. The value that goes inside of the square brackets is called an index. So every bucket on our array, every bucket on our diagram has an index associated with it. So the first index is actually index 0. The next index is index 1, index 2, index 3, and finally the last index for this particular example would be index 4. So arrays have two kinds of values, two kinds of data associated with them. The values, this is like the actual buckets where the data is being stored. Whereas the index is like an address. Which bucket am I talking about? Which position within the array am I trying to read or am I trying to put data into? Okay? So This is a more accurate description, I think, of what our program looks like when we first start up this coding example here. So when it says to print out whatever is in this array at position 0, that's as simple as going to index 0 and then looking at the associated value, which is 0, because I haven't actually put anything else in this array yet. It's empty, right? It's a brand new empty array. If you run the code, you'll see that, in fact, 0 is the first thing that's going to get printed out. But how do I change this then? How do I come back through and make sure that these values aren't zeros? They're actually meaningful data to us. We need to assign. We need to actually assign values to these positions. And we're going to use the same technique that we introduced in the first day of class, variable assignment. It's just now the variable that we're assigning to is an array. So using the variable name isn't enough. I have to use the variable name in association with an index. So if we look at this line right here, this says, with the array called high scores, go to index 0 and put the value of 99 there. So after this line of code executes, if I update my diagram, it's going to look like this. Okay? And then if I go to the next line of code, this says go to index 1 of that array and insert the value of 98. So that line is going to have the effect of doing this. And so we'll, proceed through. Here's index 2, 3, and 4, 98, 88, and 68. Notice something, though, about the size of the array and the index values. The size of this array, the length of this array is 5, but the last index is not 5, it is 4. And actually, if I made an array with a size of 3, my last index would not be 3, it would be 2. Why is that? It has to do with something that I already mentioned, actually. Yeah. Because we started at 0, because array indexes start at 0. And that's not a choice that's up to us. That's just how it works. The index always starts at 0. We don't get to pick that. That's not something that we get to control. So if the array has a length of 100, I know that the last index that I'm going to be able to use is not 100, but 99. It's always one less than the length because we start counting from 0. Does that make sense? It's an important property, in fact, one that you'll almost certainly see on the upcoming exam next week in some form, right? That's a common thing for us to ask about on the exam. So then if we want to, take a look at what happens down here, notice that I'm printing out the same bucket as before. I'm printing out bucket 0, but the difference is that in between the first time and the second time I print out bucket 0, I actually put something in to bucket 0, right? It is no longer empty, but it actually has a value, which is why we see that 99. If I put in the 3, if I switch this to a 3, what am I going to see printed instead of the 99? If I say print out bucket number 3, well, we can look right up here and see that bucket number 3 was set to 88, or you can even refer back over here. Here's bucket number 3, here's index number 3, the value is 88. So hopefully, when I run it again this time, after making that change, I see, 88 is the value that I get back out. Everybody with me? Everybody with me? Any questions before I move on to the next one? Okay, awesome. So let's talk about array traversal. An array traversal is a very common operation. What I mean by an array traversal is that I'm given a collection of data and I'm going to visit each element of that array one time. That's called an array traversal. Typically we start at the front of the array, the beginning of the array, and we work our way towards the end. But we can also go backwards. We can also start at the end of the array and work our way back towards the beginning. In fact, it might be appropriate to do that. It's kind of up to us to determine, based on what problem we're solving, which way is the most appropriate. But by far, the most common way to do it is to start at the beginning, start at index 0, and work your way down towards the end. And so the example that I'm going to show you is an example of a loop that I've run written / run so many times in my life, and one that you will almost certainly be asked to write on a quiz or an exam coming up in the next week or so. Let's take a look at this guy, the for loop. This is a good time to also review some stuff from last week, since we talked about for loops last week. What's this part called of the for loop? Initialization. Then we have, what's that part called? The test case or the condition. And then finally, this last one, I kind of heard that one. This one's maybe, I call it the update. Some people call it increment, which is mostly correct, but we don't have to go up by just one. We can go up or down by whatever we want. So it's an update, right? How are we updating our loop variable? And all for loops that we write all of this style of for loops are going to have those three pieces. The big difference between the for loops we showed you last week and the ones that I'm showing you right now is this part right here, right? With the condition. Notice that the condition is based on the size of the array. That turns out to be very important. So think about it. I'm starting at position 0. Well, that makes a lot of sense because our first index is 0. And then I'm gonna keep incrementing I by 1 until it is, notice it's strictly less than here, the length of the array. So if the array has, how many things does this array have in it? 1, 2, 3, 4, it has 5 things in it. What is I gonna do? I is gonna go 0, 1, 2, 3, 4. Once it gets to 5, once I is equal to 5, this is actually going to be false. And it will stop, which is actually what we want. This array will visit each element, this loop, I misspoke, will visit each element exactly one time, and in this case, it will print it out. In other situations, especially if we're dealing with numbers instead of text, we may want to do some math or some other operations with the data in our array. But for this very simple example, we're just going to print it out. We're just going to print out the contents of this array. I'm going to run it for you and show you that that's how it works, but I actually want to do you one better and work through this example in the debugger and show you how every piece is updating along the way. So in order to do that, I'm going to go ahead and set a breakpoint. I don't know, line 8 is fine. Line 10 is also probably fine. Either one is probably fine. And then to start it in debug mode, remember you have to select debug mode or it won't stop at the breakpoint. So I'm going to go ahead and select debug. Here I am at line number 8. This is the line that's going to create our array for us. So I'm just going to go ahead and step over this. But I do want to show you that over here on the left, I see something called names, and it tells me that it's a string of 5 things. And actually, if you click on this little arrow and you expand it out, you can see that, this is quite literally, one of these, right? It's showing me one of these diagrams in VS Code. It's saying that index 1 has a value of Jamal, index 0 has a value of Jamal, index 1 has a value of Emily, index 2 has a value of Destiny, and so on and so forth. So let's take a look at our loop now. The first thing the loop is going to do is it's going to create our loop variable called I, and we said the initializer, it shows as setting I being 0. So there, in fact, is our I being set to 0. Now it says go to the names array, access the bucket at position I. Notice the I is in the brackets there. So the first time through the loop, I is 0. It's going to extract whatever name it finds at index 0, which in this case is Jamal, and it's going to print that out. And there it is. Okay, but we're not done yet. So the next time through the loop, we can see that I is now updated. It has a value of 1. So I'm going to plug the value of 1 in as the index to this array. So the value that gets printed out this time should be the value at index 1, which is Emily. There it goes. And every time through the loop, we can actually see this process. I goes up, which means that the next time through the loop, I print out index 2, and then finally index 3, and index 4. And once I is equal to 4, it is going to add one more to it, which is going to cause this condition to be false. And now our loop is over, and our program is over for that matter. This is, yeah, we don't need to look at this code. That's not something we care about. This is the, where did my example go? I closed the tab that had my code in it. I'm sorry about that. This is a classic example of using a loop to perform an array traversal. If I know that I need to perform an array traversal, I'm writing a loop that looks like this. The only difference is that the name of my array goes here, right? Notice there's some other nice qualities about the way that this is written. If I come up here and I add more names to it, so let's put my name in there, for example. And Professor Nuri's name in there, for example. So now, instead of just having 5 names in it, it has 7. I added 2 more. But because I used names.length here, I don't have to change this loop at all. The next time I run the code, it's going to automatically say, oh, there's 7 things in this loop. I'm sorry, in this array. So my loop variable is going to iterate through those 7 things. In fact, a quick run of the program will show you that, yes, it adapted as the size of the array went up. This loop did not require any edits, didn't require any changes, just worked with whatever array it's been given. So this is sort of the classic way of viewing the contents of an array. In fact, I want to contrast that with something else real quick. What if I try to do, here it's just showing me the contents of the array, right? Can't I just do this? Why can't I just do this? Let's try it. Let's try it out. Why can't I just print out the names array? Okay, so this stuff is from my loop. The line that got printed out from line number 10 is right here. That's what got printed out as a result of line number 10. That is what the computer is telling us our array looks like. This does mean something. This isn't just garbage. It's not junk. It does mean something, but it's not very helpful to us. What this actually means, if you really want to know what it means, this number right here, that is a number. I know it has letters, but it's a number. That is the actual position on my computer where this array is. And your number is probably different than that, because that's the actual position on your computer where the array is, right? So it's not nothing, but it's also not useful to us. We are not going to ask you for that information ever in this class. It's not relevant. This is not how we print out arrays. This is not how it is done. In order to print out an array, in order to see the contents of an array, we have to perform an array traversal. It is required, it is necessary for us to perform an array traversal. And that's not the only reason. There are many, many, many other reasons why you might want to write a loop to traverse an array, which is why we're talking about this so much. But let's take a look at an example of what can happen when things don't go according to plan. I want to take a look at some common mistakes, common errors that may occur as you're trying to do this. So here's an example. I'm creating an integer array called scores. And I can see that there are 4 values in it, 10, 9, 8, 7. And this loop is trying to do an array traversal and print out all of these values. But if I run this code, what actually happens, we can see that, okay, I got 9, 8, 7. Well, okay, 9, 8, 7. Where'd the 10 go? And also, I got this fun little thing down here. Exception in thread main. Oh, geez, that doesn't look good. Array index out of bounds exception. That's a classic. That is a classic. It is almost a guarantee that you're going to run into one of these at some points. If not this, I mean, I still get these errors all the time. It's one of the most common things to happen in all of programming. Don't freak out. If you see a message like this, I know it can be scary. What does this mean? What did I do wrong? How do I fix this problem? It's trying to help you out. It's trying to tell you how to fix this problem, or at least give you more information about what the problem is. It's saying that index 4 is out of bounds for, can I scroll over? Oh yeah, I don't have to scroll over. For length 4. Or a more, I guess, English way of saying that would be the array has a length of 4, and you tried to access index number 4, which we just talked about a few minutes ago. That's not going to work. The biggest index that I can access for an array of length 4 is 3. So I went too far. An array index out of bounds exception happens when you go off the end of the array. You ask for a bucket that doesn't exist. There's 10 things in the array and you ask for bucket number 75. Well, there isn't a bucket 75. You went off the edge of the array. You can also go off the other end of the array. It's less common, but if I ask for bucket, -2, well, that also doesn't exist, right? There is no bucket -2. What buckets do I have? I have buckets starting at 0 up to the length -1. The length of the array -1. So if we look at this loop then, there's 2 errors that I see. Can somebody point out one of the 2 for me? Yes? Yeah, so this is a common one because, again, as humans, we like to start counting from 1, but in computer science class, we really like to start counting from 0, especially if we're using arrays. If you're using arrays and writing loops, starting your loop variable at 0, 99% of the time, is a pretty good idea. Yeah. What's the other problem? Yes? Exactly. So we don't want to do less than or equal to here. We want to do strictly less than. If we say less than or equal to, we're saying that this is an allowable value for our loop. It's an allowable index into our array, and that's not true. That's not correct. But this is really like a formula that I use in my head, even just like any formula in math class. If I'm writing a loop to traverse an array, I'm going to start my loop variable at 0. I'm always going to use strictly less than the length of the array. And that'll work every time. That'll work every single time. So, this is the way to go when doing array traversals, 100%. Any questions about this before I move on to the next? So I want to show you, actually, I know last week is when we showed you how to do for loops and while loops. I'm actually going to show you a third type of loop today that works particularly well with data structures, with arrays. This kind of loop that we're writing, this kind of an array traversal, I would call I'm iterating by index. So my loop variable is taking on each value of the index one at a time, and then I'm using that index to retrieve values out of the array. We can actually leave the index out of the equation entirely if we want to. So there's another style of for loop where if the index is irrelevant to us, we don't care about the actual positions, we don't care about the address, we just care about the data, we can write a different style of loop called a for each loop. So I want to take a look at one of those and kind of compare and contrast the two. Here's an example of a for each loop. You can see we've got 2 arrays. I've got one that has integers, I've got one that has strings in it, and here's my loop. And you'll notice it looks pretty different to the style of for loops that we've been showing you into this class up until this point. That's because this is a for each loop. So the way that I read this is I say for each integer value in the high scores array. That's how I pronounce that in English. For each integer value in the high scores array, print out that value. How do you write one of these? What's the structure? This is a loop variable. Notice that I don't set it equal to anything, right? I don't say int value equals 0 here. I just have to declare it. This type, the int, is always going to be the same as the type of the array that you're trying to iterate through, because the purpose of this is to take on each one of these values one at a time. So the first time through this loop, this variable will be 10. The second time through this loop, value will be 9. The third time through this loop, value will be 8. Contrast that with the style of loop that we saw before, where the first time through the loop it's 0, 1, 2, 3. Those are the indices, which I can use to grab stuff out of the array. But with a for each loop, we're basically saying, forget about the index. I don't care about the index. I just want the values. We can use the for each loop to access those values directly. So another way of doing this, or I think a good exercise, what I would like to do is to actually rewrite this, right? here's the for each loop. Let me write it for you as kind of the old style loop and show you the equivalents. And we'll run both through the debugger and show you how they work in a little bit more detail. If I was doing this the old way, again, it's a formula. It's a formula. So the array traversal loop that I just showed you would say int I is equal to 0. I is less than I scores dot length, I plus plus, system dot out dot println high scores at I. My claim, which I hope to prove to you using the debugger here in just a moment, is that these two loops are equivalent in terms of what they will print out. How they do it is a little different, right? They both get us to the same endpoint, but the way that they take us there is a little bit different. That's the point I'm trying to make here. They both show us what's in our arrays, but the way they do it is a little bit different. I'm going to set a breakpoint here on line 11 for the for each loop and step you through that one, and then we'll take another step through the traditional array traversal and kind of compare and contrast the two. All right, so here we are at our for each loop, and we can see that this is what our array looks like, 10, 9, 8, 8. This variable value doesn't exist yet, but as soon as we step through, we'll see that value should have gotten created, and it has a value of 10. Notice that it doesn't take on a value of an index, it takes on one of the values from the array directly. We're leaving the index out of the equation. For each loops do not use the index. Not an important thing for a for each loop. So then the next time through the loop, value has a value of 9. The next time through the loop, value has a value of 8. And then the final trip through the loop, value has a value of 8 again, since 8 appears twice. And if we look down here at the bottom, we can see that all 4 of those values did in fact get printed, 10, 9, 8, 8. Once this for each loop has visited each of these values one time, it's over, it's done. But let's contrast that with the way that this loop works, which again is going to do the same thing, just a little bit differently. For this loop, our loop variable isn't taking on the values of the array, it's taking on the different indexes, the different indices, starting with index 0. So here I can see I is 0, and then it says go to the array at index I, which is 0, and print out that value, which we know to be 10. So there's the 10. The next time through the loop, our index goes up by 1, so now we're going to print out the value at index 1, the value at index 2, and then finally the value at index 3. At that point in time, our loop variable will be equal to the length of the array, which should tell the array to quit. And if we take a look finally down here at the bottom, you can see I got the same thing printed out twice, right? Once using a for each loop, once using the more traditional loop style. Both of these do the same exact thing, it's just the way they do it's a little bit different. Does anybody have any questions about that or the differences between these two loops? Now, why am I telling you all this? That's kind of the question that I expected somebody to ask me, is like, why would I ever choose one of these over the other? I think that's an important thing to think about. I want to say, for starters, that doing it this way will almost always work, regardless of what you're trying to do. With an array, this style, you can't really go wrong. This style is considered to be more convenient. It's like a shortcut in a lot of cases, because it leaves the index out. But if it turns out that I actually need the index for something, which can very much be true, then we run into a problem using this style of loop, because I don't have that index readily available. Another way to think about it is that in this case, in both of these loops, I'm not putting anything into the arrays, I'm only taking things out of the arrays and showing them to you. But let's think about that opposite direction for a moment. If I want to put things into an array, what's the better way to go? A for each loop or one of these more traditional for loops? And there's an example actually that shows that exact situation that I want to walk through with you really quick, which is this one right here. What we want to do is we have an array of numbers, and I just want to go through and I want to bump each of these numbers up by 1. So by the time this code is done, I want this to be 7, 3, 2, 8, right? I just want to add 1 to each one of these values in the array. Seems straightforward enough, seems simple enough. If we try to use a for each loop to do it though, here's what that looks like. Grab a value out of the array, add 1 to it. But does that actually change the contents of the array? That's kind of the million-dollar question with this example, is that, well, yes, I am manipulating a value and adding 1 to it. Is that a temporary change, or is it a permanent change? Is it actually changing the values in my array, or is it only changing the values that I see on the screen? Because there's a big difference, right? There's a big difference between what gets shown to me and what the computer actually remembers, what the computer is actually storing as a variable in its collection. So let me run through this one for you in the debugger, and it'll should be able to show you pretty quickly here what happens when you try to do something like this. Here's my array of values. You can see all those values over here in the debugger. And it's trying to extract the value out, which I believe it will do successfully. Here's the first 6. And it wants to add 1 to it, which it very easily does. It's now 7. But hold on a second. If I look at the array at index 0, I don't see a 7, right? So I didn't actually make this change permanent. It's only temporary. I didn't actually update the value within the array. I only updated this one variable. And yeah, it looks like it gets printed out, but if I look at my actual array, it still has the old value in it. I want that to be 7. Forever. Permanently. Right? So, okay. In this case, for each, this is another example where for each loop, not the right tool for the job. For each loops are great for printing out the contents of an array, for reading stuff out of an array. For each loops are bad for putting things into an array. Bad for putting new data into an array. To do this problem properly, if we wanted to properly write a loop that would add 1 to all of these values, we would need to use the other style of loop, which again, this is a formula. I'm writing this out so quickly because I've internalized array traversal in my head as a formula. Start at 0, I is less than values.length, the name of my array.length, I++. Whoops, got too many brackets here. I could do this all in one line, but I might break it up into 2 lines just to kind of illustrate a little bit more clearly what's going on. I can bring out a value from the array by saying a line like this. I can add 1 to it, right? And then I can put the value back into the array like this. You could actually do this all in one line, but I wanted to kind of break it into the different steps so that you could see more clearly what's going on. And let's run this one through the debugger again and see how it acts differently compared to the prior example when we had our for each loop. So now we're iterating by index, not by value, but by index. So I is 0, says grab the first value out at position 0, which is 6. We're going to add 1 to that to make it 7, and then we're going to put it back into the array at the same position where we got it from. So I removed it from, I took it out of the array, did something to it, and now I'm going to put it back into the array. And so I think the important thing to pay attention to is this bucket right here. You can see now, yes, now that bucket is 7. Now I have done what I intended to do, which is to change the actual data itself. And continuing to run through this, we'll do the same process, one index at a time. There is the next value that just went, for I is equal to 1, and the next value, and the next value, and so on and so forth. All right. So to recap, for each loops, people like them a lot. They're actually fairly common. especially in other languages, maybe not quite so much in Java as in some other languages, but they are very common. You will see them. They're great for extracting data out of arrays, not so good for putting data into arrays, but fortunately, we can iterate by index. And if this whole conversation is pretty confusing to you and you're like, I still don't quite know the difference between a for each loop and a regular old for loop, use the regular old for loop. 99 times out of 100, maybe even 100 times out of 100. The regular old for loop, iterating by index, will get you there. For each loop is considered kind of a shortcut. Any questions on that before we move on to our next topic? Yes?
Do for each loops take less computing power than for loops?
Do they take less computing power? Theoretically, they do a little bit. It requires less data, right? I'm not tracking the index, so that's less computation, that's less information that I'm tracking. It's pretty negligible, though, I would say. It's more for humans than the computer.
So why not just use a for loop every time? When would for each loop be uniquely useful?
The argument in favor of a for each loop is that there are fewer parts here, and so when we do things in coding, it's usually for one of two reasons: either because it makes the code work better, or because it's easier for the people who are working. And the for each loop falls in that second category. For each loop is for the people who are working on the code. The argument is that these loops are a little bit more natural for humans, because that for each is a more English way of approaching the problem. So, yeah, no, great question. Thanks for asking. One more big important topic before we wrap up and do the quiz at the end of class here. So all the arrays that I have been showing you so far have been what we call one-dimensional arrays. I don't know how many of you have taken matrix or linear algebra classes, and maybe you don't have to. I don't know what your major requires, but they're row vectors or column vectors would be another way of thinking about it. You can actually see in the diagram that I put here, right? It's a single column. Or you could interpret it as a single row. That would also be okay. But we're not limited to just one dimension. In fact, we can have arrays go up to multiple dimensions. For the purposes of this class, I'm going to promise you that the upper bound on dimensions is 2. I don't think we're ever going to ask you anything with more than 2 dimensions in it. But from the computer's perspective, they're not limited by the number of dimensions. In fact, they're not even limited by the number of physical dimensions. I can have an array with 100 dimensions on it if I want to. The computer doesn't care. The computer will be able to keep track of all of that stuff. But we're going to keep it simple. We're going to talk about a 2-dimensional array, since these are very, very common styles of arrays. And let's take a look at an example of one. In the 2-dimensional array, we see that we've got this line of code right here that looks very similar to the line of code that I showed you at the beginning of class, except for now I see 2 square brackets, right? And that's your first clue, that I'm dealing with not a 1-dimensional array, but a 2-dimensional array. And then over here, we have the same thing, right? I don't see just one value, I see 2 values. So 2 dimensions, that means that I'm no longer talking about a straight line, I'm talking about a rectangle. So these 2 values are representing the 2 dimensions that we have. 2 brackets for 2 dimensions. This first bracket is always going to be referencing the rows. The second bracket is always going to be referencing the columns. Always, always, always. So this is saying that I want to create a 2-dimensional array that has 2 rows and 3 columns. Okay? Let me illustrate that on my spreadsheet. Oh, there we go. So 2 rows and 3 columns, it's going to look something like this. Right? 2 rows and 3 columns. Actually, let me give myself a little bit more space here. A little bit more room to work with. 2 rows and 3 columns. Because it is an empty integer array, right? Just like we saw before, these are all going to be zeros to start with. 0, 0. So these are all empty. Oops. But let's talk about the index situation. 1 index isn't enough. Because it's a 2-dimensional array, we have two indices, or in other words, one index value. If I want to get to this location, I can't just use one index to do it. I have to give you a row and a column to get to that particular spot, right? So the index for the rows is going to start from 0 and count up. So that's row 0. This is row 1. And the index for the columns is going to start from 0 and count up. So this is column 0. This is column 1, and this is column 2. So if I want to access a position, any of these positions in green, like this one, for example, the row always comes first. So I would say that this is at position 0, 1. Row 0, column 1 gets me to that spot. And in code, we would actually see multiple brackets used to say that. So if I wanted to print out the value at that position, I can't just say ticket info bracket 0. That's not enough. It's a two-dimensional array. Bracket 0 is an entire row, right? Bracket 0 would be all of this. So that's not enough information to get me to just one value. I need to include a column as well. So I'm going to have a second bracket after it that says column 1. So that's how we access a two-dimensional array. Everything else that we've talked about up until this point is the same, except we just have to remember to have that second dimension. So if I want to store a value in this position, right, I could say this equals something, right? And if I want to get the value out, I just need to have 2. Another thing that's worth talking about is, what does length mean? What does length mean? Because there's really 2 lengths now, right? There's really 2 lengths. I have the number of rows and the number of columns. So if we just print out the length of a two-dimensional array, ticket info.length, it tells us the number of rows, just the number of rows. If I want to know the number of columns, this is something that I would encourage you to highlight, draw a star around, whatever you need to do to remember this particular expression in your notes, right? This is how I would access the number of columns for a given array. It's a little bit confusing though, so let me try and break it down a little bit. What I'm saying is, go to row 0, and tell me how long row 0 is. The length of a row, as we can see from our diagram, is equal to the number of columns that we have. So if I just say the length by itself, that's going to tell me how many rows I've got. If I ask for the length of always row 0, always row 0, because I don't even know if there will be more than one row, right? I don't know. Also, too, I think it's important to note that all of the two-dimensional arrays, at least in this class, will be rectangular. There will not be rows that are longer and rows that are shorter. They will all be the same. It will be a rectangle, right? It will be a rectangle. But yeah, if I want to know the number of rows, I use .length. If I want to know the number of columns, I ask for the length of the first row. And that tells me the number of columns. And then finally, the last thing that I want to show you, which is a very, very important concept and kind of one of the main concepts from last week as well, actually, is array traversal with a two-dimensional array. It relies on a nested loop structure, like Dr. Nuri showed you at the end of class last week. So this is the final example that I'm hoping to get through for today. For starters, actually, let's take a look at this. Notice this is how we create, we use that array creation shortcut. Notice though that for a two-dimensional array, I've got an outer set of brackets, and then this is the first row, and this is the second row. So that's how we can use this to specify a two-dimensional array if we want to. So after this line of code gets executed, I think I'm going to try and follow along with the diagram on this one. It's going to look like this. 1, 2, 3, 4, 5, 6. So this is what our array looks like, and these are, remember, the column indexes and the row indexes for our two-dimensional array. So we create some values here. I'm not even too concerned about these variables right now. What I'm more concerned about is this. This is a nested loop structure. I know that you all have been thinking about this because I had some of you in my office hours this morning asking me to go through some practice problems on nested loops, which is great. I love being able to do that with you. Very happy to walk through any of the practice problems. You're going to see nested loops a lot with two-dimensional arrays. And the reason is that we use one loop for the rows, and we use the second loop for the columns. One loop per dimension. One loop per dimension. But it's important to understand how these nested loops interact with each other. I think it's also important to understand how this two-dimensional array traversal is working. So consider, you'll notice actually before I run this code that both of them do start at 0. Row is less than a dot length. That's just like we saw for a one-dimensional array, right? For the second loop though, notice column is less than a bracket 0 dot. So this is the number of columns. This is the expression that I told you we use for the number of columns, correct? So this outer loop is going to iterate one time for each row. This inner loop is going to iterate one time for each column. But they interact with each other. They're not independent. The column loop is inside of the row loop. So how does it actually work in practice? Let's set the debugger and use our diagram and kind of walk through this a little bit, see if we can understand how this is going to traverse through our array. This is actually even good practice for the quiz that you're about to take here in just a moment. Here's our array. You can see it's got two rows, row 0 and row 1. So in order to see the contents, we actually have to expand one of the rows, which is interesting. But I'm more interested in these nested for loops. My row starts out at 0. My column also starts out at 0. So the very first value that I'm going to look at is at position 0, 0, which is the top left corner. That's almost always how we view our two-dimensional arrays, with 0, 0 in the top left corner. Which value is going to change next, the row or the column? Based on what you see here, which value is going to change next, the row or the column? The column is going to change next. The inner loop cycles faster, quote unquote, than the outer loop does. So the row is going to remain constant while the column goes up. So after we do our math or whatever, I'm not interested in the math, I'm more interested in the loops. We can see that the row is at 0 and the column is now at 1. So the next value that I'm looking at is this one. And if I keep going, we'll see that the column is going to go up again. Row 0, column 2. I'm now looking at this one. That's the last column, right? That's the end of my row. So let's take a peek at what's going to happen next. I keep progressing through. The inner loop is now over. You can see the column just poof disappeared because that loop's now over. But excuse me. Excuse me, sorry about that. The outer loop still has work to do. The outer loop is not over yet. So the outer loop is going to bump the row up to 1. And then the inner loop, this loop, is going to start all over again. This is one of the things that I talk to students about a lot, actually, when they were coming to ask me questions about this nested loop structure. This entire loop is going to get repeated from the very beginning. Right? So now the space I'm looking at is row 1, column 0. So I finished the top row. I'm now here. I've moved down to the next row. And then I'm going to go ahead and keep stepping through and see that, okay, now column is at 1. So I moved to this spot. And if I keep on stepping through, I'll see column is equal to 2, which means I hit this spot. So how did I traverse this two-dimensional array? I started at the top left corner. I went across the row, went down to the next row, went across, and if there were more rows, which I know there aren't, step down, go across, step down, go across. It's just like reading a book. Just like reading text. Start at the top left, read across till you hit the end, go down to the next one, read across till you hit the end, go down to the next one, read across till you hit the end. This is the standard way of iterating through a two-dimensional array, traversing through a two-dimensional array. It is not the only way. It is not the only way. Consider that I have control over it. This is the way that I would do it for 95% of the time that I want to traverse a two-dimensional array. But consider, what if I were to swap the two loops? What if I just took these two loops? I'm not actually going to do this, but what if I actually took these two loops and just swapped them? Took that line of code and swapped it and put the other one down. How would that affect my traversal? What order would I be visiting the data then? Down the columns. I would start in the top left corner and go down the column, and then move over to the next column, and then move over to the next column. Is that a good thing? Is that a bad thing? I mean, yeah, it's a good thing if that's what you need to do, right? If that's how your data is structured and that's how you need to visit, it's up to you as the programmer to make that determination. Sometimes it won't matter. Sometimes I could do it across the rows or down the columns, and I'll get the same place either way. It doesn't matter. It makes no difference whatsoever. Other times it will matter, and it's up to the problem that you're trying to solve. It's up to you as the programmer to, have that knowledge and make that judgment. Any questions before we switch over to the quiz? All right, go ahead and put all your electronics away. No phones, no laptops out. You should have gotten a quiz sheet when you walked in. I'll put the quiz up here in just a moment, but to remind you, you need to hand the quiz to either myself or Professor Nuri once you're done with the quiz. So that's, don't just leave it on a table somewhere. Hand it to one of us, please. I'm going to give you 1 minute to put stuff away, and then I will put the quiz up. All right, everybody. What time did you get here, man? Okay, I'll let it go this time. We don't want people just coming to take the quiz, though, right at the end.